Hello everyone, I have a new pen. So I hope mas maganda na yung sulat ko ngayon. Ah, yeah. Okay, so let me go back with transmission line parameters. Basically, ang natapos natin last time ay uh, I'm done with introduction of the transmission line parameters, yung ating saan ba natin makikita yung ating line resistance, line inductance, and then yung capacitance di pa tayo nakakapagsimula doon. But yeah, there is capacitance. And then I think napadaanan natin yung skin effect. So yeah, it's a short definition. We are assuming uniform flux density. So current density. Sorry, we are assuming uniform current density. So we are basically neglecting skin effect. And then on my previous videos, ano nga to? Yung ating internal inductance and external inductance. Okay, so resistance is very simple, madali lang siya. Naturo ko na yun sa inyo before. On inductance, we have two components for inductance. Yung ating internal inductance, that's within the conductor, and then yung ating external inductance that is due to the magnetic field outside the conductor. Okay? So I think mag-recap muna tayo saglit dun sa inductance natin kasi yun yung medyo mahabang i-discuss. I won't go with the derivations anymore kasi tapos ko na siya. But this is the basic definition of your inductance. Oops. Sorry. Yan. Oh, ayaw niya. Hello. Ayun. Okay. So this is inductance. It's basically the magnetic flux linkage over current. Okay. So I'm gonna skip the derivation. This is the formula that you want for internal inductance. This formula, it's 0.5 times 10 to the negative 7 Henry per meter. Again, take note, all of these parameters are in per meter kasi we are assuming that we are taking the derivation from a line that is 1 meter in length. So naka per unit length tayo na per meter. You may want to remember this 0.5 times 10 to the negative 7, or if you want, you can use mu naught over 8 pi. Parehas lang naman sila. Well, you have your mu naught on your calculator and pi on your calculator. So yeah. Okay. Now on the external inductance, we have the same derivation. Then we'll end up with this formula. So L external, internal inductance is 2 times 10 to the negative 7, such that what will happen here is, I think I have it here. Palit tayo ng kulay ng ano. Gawin natin blue. Yan. The total inductance is the internal inductance plus the external inductance. So, ganun lang siya. So, it's 0.5. Uy, gumagalaw ang aking 0.5 times 10 to the negative 7. Ay, yun. Nag-cut yata. Wala, di yata maganda yung pen ko. Anyways, plus 2 times 10 to the negative 7. Take note, times ln ng d2 over d1, where this d1 is basically the radius of the conductor. Okay? And then on my previous derivation pa na nagawa na natin before, pwede natin pagsamahin itong dalawang to into a single term such that this one, ito kasing 0.5 na to, this can be represented as 2 over 4. So now you have a 2 over 4 times 10 to the negative 7. Okay? So pwede mo na ngayong ilabas si 2 times 10 to the negative 7. So meron ka na yan. And then it's just 1/4 plus ln. Okay? And then you can, well, this is d2 over r. And then you can put this 1/4 within your ln. Tama ba ako? 1/4. Yeah, okay. You can put this 1/4 within this ln. And then kapag ka nasa loob na siya, you'll end up with, dami ko ng, paano kaya magbura? Let's see. Uy, merong erase all. Ayan. Okay? So, once na meron ka na nun, you can have 2 times 10 to the negative 7. And then, yung 1/4 natin, ilagay natin sa loob ng ln. So, what will end up with r prime. And this r prime just the radius times e raised to negative 0.25. So kung paano siya nangyari, it's basically I guess it's advanced math. Okay? So yeah, ganun lang siya. And then take note, this is just for a single conductor. From our previous lecture then, we also discussed kung ano ba yung effect ng multiple conductors. Ang multiple conductors on our inductance. So ano ba yung nagiging effect ni conductor 2, conductor 3, conductor N sa inductance ni conductor 1? So of course, if may effect si 2, 3 up to N conductors kay conductor 1, therefore it would also mean that that there is an effect kay conductor 2, sorry. Palitan natin ng ganyan. May effect din kay conductor 2, yung conductors 3, conductors 1, and conductors N, and so on and so forth. Okay? And the formula that you want to remember in this derivation, previous derivation before, is this one. And yeah, no, ito. Okay? Andito pa lang tayo. So it's more like an extension of our 2 times 10 to the negative 7. You see, nung hindi pa natin kino-consider itong mga conductors na to, back when we were not yet considering these two conductors, ang formula natin ng inductance is 2 times 10 to the negative 7 ln ng d2 over r prime. Okay, where this d2 is a point in space na tinawag natin p that is very, very far away. Okay? Na later on, napakita natin na, later on, napakita natin that if it's very, very far away, then we can just neglect it and simplify the formula into something like this. Wait, ayaw. Nagka-cut ang aking I don't know why. So, ba't ba siya? Okay, sige. And simplify the formula into something that looks like this. 2 times 10 to the negative 7 ln ng 1 over r prime. So, yan na yan. So, sir, where is I? Nasaan yung I dito? Kasi there should be an I here. Take note na nung wala yung I na yan, this is already equal to L. Okay? Now, this formula here, this long equation here, this is not yet L. That is not yet the inductance. Kasi hindi pa natin kayang kunin yung inductance. We cannot get the inductance yet because these I's are different from each other. So, hindi natin sila kaya cancel. We cannot cancel that. So, that's why this formula, this whole formula here is just the formula for linkage. Okay? So, yun lang muna. Yun lang muna yung meron tayo. Now, let's try looking at this single phase line. Okay? So, what we want to what I want to emphasize here is that single phase pa lang siya. So this is your network here. I think hindi na respond properly anyways, sige. Let's see. So I think what I want to emphasize here is single phase lang siya. So this is your source. And then this is your load. So yan lang muna. Okay? So you have these lines here. This is your line going to the load from the source, and then this is your return path from the load to the source. Okay? So when we use the same derivation na ginawa natin on the mutual flux linkage between multiple conductors, so you'll end up with this equation. So yan. So let's say that this is conductor 1 and let's say that this is conductor 2. So if you use this as conductor 1, kaya ko ba itong delete? Yeah. Okay. So if this is conductor 1, then its flux linkage, then its inductance will be dependent on the flux linkage that is due to itself and due to conductor 2, this one. That's why you have this formula here. This one multiplied to this one, that is due to itself. That's its internal plus external. And then due to current 1, due to the current flowing here, this is current 1. Now this one here times this one, that is due to the current here. So as you can see, this current here, this current at conductor 2 has an effect on the inductance on conductor 1. Okay? Now, what do we know about these two currents? What do we know about I2? This is I2 and I1. Since this is a single phase line, then we can say that I2 is just negative of I1. They are the same in magnitude but opposite in direction. Kasi yung isa is going to the load, yung isa is going to the source. So, bumalik siya. Okay, so that's, so ganun natin siya makikita. I guess, ang isa pang, ano rito, para, in the perspective of conductor 1, yung, yung current 1 is going east, current 2 is going west. That is on the perspective of conductor 1. Okay, so, if you use this, substitute this to I2, then you'll end up with this negative I1 here. Okay, so now you have this I1 and this I1. So, iisa na lang yung current mo ngayon. Okay, and then you can put this I1 here sa labas. Pwede mo na ilagay yung I1 dito sa labas na to. And then you can just combine these two ln's. Okay, so you'll end up with ln of D over R, over R1. Actually, R1 prime siya, pero R1 siya kasi lumabas yung 1/4. Doon din ba? Ay, okay. Lumabas lang. So, yeah. So, basically, yun na yan. Okay? So, that's how you do it on a single phase system. Okay? And I think, in terms of, take note, naka-L na tayo. Kasi your magnetic flux linkage, your L, your L is equal to flux linkage over I. But since now, iisa na lang yung current natin, it's both I1, both of the currents in the terms are I1. So kaya na natin siyang i-divide and to get L. Okay? So yeah, that's how you get L. Now I think what I want to for you to take note here is that this distance D is the distance from the centers. Okay? So yun. So yeah, this is R1 prime. It's R, hindi pala siya R1E. Mali ata yung nasulat ko kanina. Kasi yung nasulat ko yata kanina, R1 raised to E. Raised to ano? No. That's okay. It should be R1 E raised to negative 0.25 or raised to 1/4. Negative 1/4. Okay? Yeah, sorry. I think I made that mistake earlier. Okay? So I think yun lang muna yung gusto ko ipakita. How do we cancel I? Yeah. So yeah, that's how you cancel I for you to get to inductance. Kasi kung hindi mo yung maka-cancel si I, you'll be left with the magnetic flux linkage. Okay? So in our next discussion, I'll be discussing naman paano kung tayo ay naka three-phase system. Okay? But for this course, take note that we are assuming na yung system natin is balanced. So, the currents are balanced. So, I guess, yun muna yung gagawin natin. So yeah, somehow, we'll end up with a current that can be cancelled. Okay, I'll show that to you later, but for this video, I think hanggang doon lang muna. Okay, so thank you. I'll see you sometime.